All right, so let's say we're looking at salary, and this is actually biological sex, but we have male and female, and then the total is just a total column of these two columns. So if we want to see if there's some kind of relationship in between biological sex and income level, we can run a chi-squared test here. I'm going to copy the data. Maybe I'll go ahead through the first couple. So the null hypothesis is always the nothing hypothesis. In other words, they're independent. They have no connection with each other. So this is going to be our first answer here. And then we have some specific values. Let me go ahead and shift now over to the spreadsheet so we can figure out what some of these are. All right, so I'm just going to paste the data that I had before. And these are our observed values. These were the actual data values they collected. The next thing we want to do, maybe I'll put these in, I don't know, green or something. And now we want to do, these are observed. And let's get a caret there. All right, now expected, we can basically copy the, maybe I'm going to do it here. We can basically copy the chart, except these right here should be out. I'm going to copy this in a different color now. You don't have to do any of this color coding, of course. This is just for helping you to see that the observed and the expected are different. So how do we figure out what the expected would be? Well, it's basically saying that if there's 110 males and 114 females, we should have a little bit less males than females in each one of these categories. And specifically, we know how many are in that category. So one way I like to think of it is we're taking, this is the portion of all the sample that's male, right? It's 110 out of 224 are male. And then we're going to multiply that by how many have an income of below 25,000. So if there really is no relationship between the two, we'd expect about this many. And then I'm going to freeze, let's see, I'm going to freeze that 13 and freeze this D, freeze both of these. Okay, notice what I did there. Freeze the 13, so I keep that total column. I keep this total column, and I keep the overall total. But I don't keep too much so that when I drag down, let's see, what did I, oops, times, oh, D, oh, sorry, I overlooked that. There we go. Now if we copy these down and these down here. So what we ideally want to do now is see how far off what we actually saw and what we would have seen if there was completely no connection whatsoever. So this is our chi-squared. And we can even copy that chart again, to be honest. Let's do that, and we'll do it in a JMU purple maybe. And we'll get rid of all of this now. Okay, so how do we get our chi-squared statistic? So we're going to take observed, remember that's this first, the actual data, minus the expected. We're going to square that, and then divide it by the expected. This will give us our chi-square value. We can then take that and fill it all the way here. This really is meaningless. And then this would just be the sum of all of these values. This is going to be our overall chi-squared statistic. So this is the chi-squared value for each specific cell, like how far we are off. For example, in the female between 25 and 50,000, we'd expect to get about 34, but we got 33.59. In other words, we were incredibly close. That's why our chi-squared is so low here. So our overall test statistic is really pretty low. Whoa, I cannot spell. And so I'm pretty sure that's not going to be significant. Just like with t-value or z-value statistic, you're trying to get further out beyond the critical value. And I'm not sure, I didn't check what the critical value is here. The degrees of freedom would be 3 because we have 4 times 2, but we have to subtract 1 from each of those. So it's the number of columns minus 1, and then times the number of number of rows minus 1 times the number of columns minus 1. So that would give us 3 degrees of freedom. Let's go ahead back to our, grab that. Now we could fill in all of these fairly. What is the expected value for men with income below 25,000? So if were expected men below 25 is 25.0. Okay, 25.0. And number of women, expected number of women, income below, so that would be right here, and that's going to be 25 point, yeah, it's going to be 26.0. Okay. Test statistic, that's what we calculated, 3 decimal places, so that should be 0.468. Degrees of freedom, remember we take number of, and when I say number of rows and columns, I'm not counting the total. So without the total, you take number of columns minus 1, so that's just 1. Number of rows, there's 4 of them, 4 rows of actual data, minus 1, so that's 3. 1 times 3. And then the critical value, so we have 3 degrees of freedom, 0.05 level of significance. We would go to the chi-squared table. So here we are, 3 degrees of freedom, 0.95. That would be, actually, hold on a second. I guess we would really just have 0.05 out in the tail. So this would be 7.815. And then make the decision. Well, we came nowhere close to getting beyond that critical value. We weren't even at 1. So we would fail to reject. We could also calculate the p-value and see if that's below 0.05, but it won't be. Okay, and the conclusion, so if we fail to reject, that's always going to be that there's not sufficient or not significant evidence that there's any connection.